Hello students, welcome back. So now we are going to be performing multivariate analysis. Multivariate means that you will be doing analysis on more than two variables, maybe three, four, five, and so on and so forth. So one of the things that we do is we actually use pair plot, and we'll be doing pair plot among MPG, weight, horsepower, displacement, and acceleration. Also, you can do group by analysis. So one example would be comparing your mean MPG by origin and cylinder. So this will fall under your group by analysis. So the first thing I do is import my pandas PD and also import my necessary visualization library. For matplotlib and seaborn, these are for visualization purposes. Then I import my CSV file. So in this case, I'm using data underscore mpg.csv. Then I print just 10 random samples just to get a feel of my data right here. So this is how my data looks like. We went over this thing in the previous session. So first we identify our categorical numerical columns. In this case, my categorical columns are origin, cylinders, and model year, and my numerical columns are MPG, displacement, horsepower, weight, and acceleration. These topics we went over these topics in the previous session. So let's start with this scatter plot among three variables. In this case, I'm using MPG versus weight versus origin. Your MPG and weight, these two are your numerical values, and this one right here, origin, is your categorical. So I'm using scatter plot over here. So I'm specifying my X is weight, Y is MPG, and my U, which is my color, is my origin. Generally, you use your U as a categorical. So in this case, origin is categorical. Also, I'm specifying my size of my marker. I want 20. And then I'm actually rendering my graph. So after I render this, you can see that you have this USA this color, Japan is this color, and European is this color. And you can see that you have a lot more data for USA because you see a lot more colors that is of this kind over here. And also you can see that USA car, they tend to have a little bit more heavier weight right here. So heavier weight translates into low mileage, low MPG. So you can draw a few observations that there is more cars from USA than Japan and Europe. Also, the cars from USA, they weigh more than Japan plus Europe. We saw that. We can see that from here by looking at these colors. USA colors are over here. Then you have, as weight goes up, the MPG goes down. That makes sense. That makes sense too, because you can see that as your weight is increasing, your weight goes in this direction, your MPG actually goes down right here. Now let's do the MPG versus weight versus cylinder. In this case, MPG and weight, these are your numericals, and cylinder, this is categorical. So in this case, my U is cylinder, and in this case, I'm using palette equals set one, also my size, and also my alpha. So in this case, I plot this graph, and let's take a look at this graph, how exactly it looks like and what it is showing. Well, you can see that 8-cylinder car, they are somewhere over here, most of these cars. Okay, and then you have 3-cylinder car. You don't see many 3-cylinder cars over here. This color, you don't see that, but you see a lot of these colors. These are your 4 and 5-cylinder cars. So one conclusion you can draw is that cars with large cylinder have more weight and give low MPG. All right, there are not many 3-cylinder cars, and also the cars with small cylinder, that is 4 and 5, that would be this right here. They have less weight and they give high MPG. You can see that these cars are clustered over here. And now let's do MPG versus weight versus cylinder versus horsepower. So in this case, my MPG is numerical, weight is numerical, cylinder is categorical, horsepower, that's numerical. So in this case, I'm using a scatter plot. My X is weight, my Y is MPG, my U, that is my color, is my cylinder, and also the size. I'm specifying my size to be horsepower. In this case, the size refers to the size of these circles right here. So these circles right here, they would indicate the horsepower. The size, the radius of the circle would indicate the horsepower. So if you have a big circle, that means it has a high horsepower, large horsepower. Okay, so let's plot that. And after I plot this, let me decrease the size of screen so it's a little bit more visible. Okay, so after I plot this, you can see that your 8-cylinder cars are over here, and then you have this 200, which is actually a large horsepower. And most of the large horsepower, they are over here. Look at the size of the circle. They are a lot bigger over here. The size of the circle over here are a lot smaller. So the size of the circle is increasing from a small circle to, like, if you go down, you can see that the size of the circle is increasing. So that tells me that the horsepower right here, as your weight increases, your horsepower also goes up. Or you can say as your horsepower goes up of a car goes up, your weight also goes up. All right, and your MPG goes down. So this way you can draw some conclusion based on this. And so in this case, what one observation I can make is that big horsepower cars, these are like large yellow circles, they have high weight and low MPG, and these are your 8-cylinder cars. You can see that these are your 8-cylinder because these are yellow, and they have high weight, large weight. And now let's do the pair plot. So in this instance, we'll be doing pair plot between three variables. In this case, one of the variables that I'm going to pick would be from here, from this one. Another variable I'm going to pick from here, and my third variable would be my origin. So in this case, I'm using pair plot, and you specify all your variables over here. My U, that is my origin. This is my color. Okay, so I'm also specifying my diagonal kind to be a kernel density estimation, and I'm also specifying my marker size. In this case, I want 10. So when I plot this, let me decrease the size of the screen again. All right, so when I plot this, we can make few observations. Let's look at this one right here. This one is telling me that your miles per gallon and your horsepower, it is like kind of inversely related. In other words, when your horsepower increases, when your horsepower goes up, your MPG actually decreases, it goes down. Okay, same thing. What about this one right here? This is telling me that when your horsepower increases, okay, your weight increases. This is your weight and this is your horsepower. So you can draw these types of conclusion. Also, you notice the color. The color over here are indicates which country they're from, which origins. In this case, is USA. So you can see the USA cars, they're like clustered very well, very tightly packed. And same thing with your Japanese and European cars, they seem to be like tightly packed. So, all right. So this way you can draw some conclusion from here. This is one of the conclusion you can draw. So I wrote few conclusions over here. Let me just increase the size screen. All right. The first one is that MPG decreases as weight and horsepower increases. We can draw that. Cars from different origin, they cluster differently, as I showed you that. And it is useful for feature intuition before modeling. So this kind of gives you a little sense of how your feature looks like and how they actually correlate with each other. And now let's do box plot. So this is pretty useful when you are doing multivariate analysis between categorical and numerical variables. So in this case, I'm choosing my cylinder palette. So in this case, I'm choosing MPG versus origin versus cylinder. So my MPG is numerical, your origin, that's your categorical, and your cylinder is also categorical. So in this case, I'm defining my custom palette for my each cylinder right here, and plotting my, defining my figure size, and I'm doing my box plot right here. So my X will be my origin, my Y is going to be miles per gallon. This generally Y is your numerical value, by the way. And your U, that will be cylinder. So this is categorical and this is categorical. And I'm specifying my palette. So this way I can distinguish each one of these colors. So I plot them, and let's take a look at these graph. Let me just decrease the size of the screen again. All right. So let's take a look at this right here. And after just giving a little quick look, you can tell that, oh, look at, there's a green over here. What is this green? This is five cylinder. So it seems like five cylinder car is only present in Europe. Okay. What about this right here? This is all the way at the bottom. What color is that? And what cylinder would that be? That would be eight cylinder right here. So this is eight cylinder from USA, and they have a low mileage. Okay. You can see that they have a low MPG. All right. And look at this one. So this color, this color, this color, they are kind of on the high end of your MPG. So what these colors are, these are your four-cylinder cars. So it seems like four-cylinder car, they give you a better mileage. Okay, so you can draw these types of conclusions. So here, fewer cylinder, which is four, gives you high MPG. That's one conclusion you can draw. The other one is that eight-cylinder cars, they have a low MPG. We just saw that. Your eight-cylinder car right here, that has a low MPG. And then only Europe has five-cylinder cars. We saw that your five-cylinder, that would be this right here, which is green, and only Europe has it. No other country has that. So I just wrote a little observation over here that your four-cylinder cars have a good MPG. We just saw that. This is your four-cylinder car. They seem to have a like better MPG because of the color. You can also see the colors are a little darker. And also there's no data for three-cylinder cars from USA. You can see that. Also, you can write more reports. So this is just small snippet of the observation. And also we can do the same thing using pivot table. So in this case, I'm specifying my index column is model year, my column is cylinder, and my value that I want to use, that I want to display on my pivot table is MPG. This is your categorical, this is your categorical, this is your numerical. So in this case, you can call pandas pivot table, specify your value. In this case, my value is MPG. Your index column is, in this case, is model year, and you specify your columns. In this case, that would be cylinder. My aggregate function that I'm using is mean in this case. So I print the pivot table. After I print it, I also want to plot this on a heat map. So I'm just using my heat map in this case. So after I plot this, let me just show you the result. So this is the pivot table result, and this is the heat map for that. So let's look at the numbers first. So in this case, it's telling me NAN. This tells me that for model year 1970, for three-cylinder car, there is no record. There is no entry over there. All right. For 1971, for three-cylinder car, again, no entry. This one right here. This one is telling me that for year 1974, for six-cylinder cars, the mean miles per gallon was 17.85. That's what this is telling me. Okay, now let's plot this thing on a heat map. So let me decrease the size of the screen so a little bit more visible. All right. So if you look at this heat map, you can draw a few conclusions. Number one, look at this darker right here. So this is your color bar. Color bar, this right here, this color means is 15. This is your mean right here, mean miles per gallon. This is your 15, and this right here is 35. So this is low number, and this is a high number. So you can see that this is a low number right here. Look at the colors; they're all low colors. So that tells me number one, that your eight-cylinder cars, their mean MPG decreased from 1979 to 1970. You can see that your mean MPG for your eight-cylinder car, that would be this. For 1979, it was 18.6, and then you can see the color actually went from a little bit dark to more brighter, so it went to 14.1 to 1970. Okay, another thing you can see that for five-cylinder, for 1989, sorry, 1980 gave a handsome mileage. Well, where's my five cylinder? Oh, look at this. Yes, it makes sense. 36.4. Look at this, is very dark in color. So this is the most dark, and you can see all the colors over here. This is actually has the most dark. So this number is very high. So that tells me that for five cylinder, your mean miles per gallon for year 1980 was very good. Okay, there is no data for five-cylinder cars from year 1970 to 1977. Well, you can tell that too for five-cylinder cars. That would be this right here. There is absolutely no data right here. You can see that there's nothing in there. So these are just few observation, few conclusion you can draw. There is a lot more you can do using data analysis using these tools. Now, if I, in this pivot table, if I change my index column from model year to origin, let's see what it does. So let's come over here, change this to origin, and let's run this. And if you come down, you can see that now, let me decrease the size again. So in this case, is a very high number, and this would be a low number. So in this case, it's telling me my high numbers are 31 points. Look at this right here. This is more darker. So for four-cylinder car, the car that came from Japan, they have a really good high mileage, 31.6. And this is a low color, which is white, almost like white in color, 16, low mileage. So in this case, it's telling me for eight-cylinder cars that came from USA, their mean miles per gallon was very low, 15. So you can tell these things by looking at the colors. And now let's do swarm plot. So now we are going to be working with MPG versus cylinder versus origin. Your MPG, that's numerical, cylinder is categorical, and this is categorical. So specify your index column, specify your call, specify your value. This is actually would be used to print out your pivot table. So in my pivot table, my values, that would be value, this would be MPG. So the aggregate function that I'm using is mean. So it's going to print out the mean of MPG. My index column would be IDX column, that would be origin. That's the one I want to use for my index. And my regular columns, that would be your cylinders. So when I print this information out, when I print my pivot table, these are the values I get right here. So let's understand this. Let's understand one of the value, 23.8388. What does it mean? It means that for Japanese car, there are six-cylinder, the mean MPG, the mean miles per gallon, is 23.88. NAN means that there is no data available for Japanese car in eight-cylinder. That's what this NAN means. Let's plot above using a swarm plot. So I'm just using a swarm plot, and in this case, you specify your X as cylinder, your Y is MPG, and your U equal to origin right here. And you plot your swarm plot, and this is how your swarm plot looks like. Let me decrease the size of the screen so it's more visible. All right. So each one of the dots in the swarm plot, that represents your data points. You can see that for three-cylinder car, there is absolutely no data except only from Japan car. So only Japanese car have three-cylinder. Look at this five-cylinder. There's only three dots over here. So that tells me for the five-cylinder car, there is no data for Japan, and I think this is green in color. So there's only European car that are five-cylinder. And then you have this one, this color. This is from USA. This is USA. This is USA. So you can see that for the four-cylinder car, your USA and Japan and Europe car, they have pretty much equal number of data. But your Japanese car, they have a better MPG. They have a good mean miles per gallon. You can see that by looking at the value too. You see Japanese car, they have better MPG, 31.59 for four-cylinder compared with 28 and 27. Okay, so what else can we draw? So these are some of the conclusion you can draw. Let me just increase the size again. So The four-cylinder car, they come from Japan, Europe, and US in equal proportion. You can see that by looking at the number of points. The number of points, they seem like pretty much same. But over here, you can see that you have more number of points of this color, USA. So that tells me that for six-cylinder car, you have more data from USA. For your eight-cylinder car, you have all the data only from USA. You don't have any data from any other car, any other country. Okay, five-cylinder cars, they can come from Europe alone. We saw that, so I wrote this over here. So by the way, this is just a few conclusion you can draw. I mean, I can go all day just drawing conclusion from this graph and from other graph. So there are some limitations of your swarm plot. Number one, they do not scale well for large data sets. In other words, when you have more than 5,000 rows. Well, that's because each data represents a point over here. So if you have more points, this can become cluttered. So it can become cluttered. Okay, in that particular instance, what you want to do, you want to use box plot or violent plot.